everyone, I welcome you all to Focus of the Day session of ANALYST IAS. In this particular session, we will discuss about the topic Nobel Prize winner in Physics 2022. We will have this discussion in the following series. First, why it is in news, followed by about quantum computing, followed by prelims practice question, followed by mains practice question. But before we start our discussion, I want you all to be informed about public administration, polity and IR and ethics classes of ANALYST IAS, which has already started from 26th of September. Along with that, we are also holding classes for current affairs. So you can inquire about any of the following course on the given number, and you can also visit our official address, that is in Old Rajinder Nagar Market. So now let's move on toward our discussion and see why it is in news. The Nobel Prize for Physics 2022 is being shared by three scientists, Alain Aspect, John F. Closure, and Anton Zelinger, for their work on quantum mechanics. The award was announced by the Royal Swedish Academy of Sciences on 4th October 2022 at Karolinska Institute in Stockholm. So this brings Nobel Prize 2022 in Physics into news. Now we will see the key highlight of this particular event. First, why it was awarded for. It was awarded for experiment with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information sciences. Then, these scientists conducted groundbreaking experiment using entangled quantum state, where two particles behave like a single unit even when they are separated. So, what is the importance of their discovery? The development of experimental tools laid the foundation for a new era of quantum technology. And being able to manipulate and manage quantum state and all their layers of property, it gives us an access to tools with unexpected potential. Now we will see the individual contribution of every scientist. John Closure, he built an apparatus that emitted two entangled photons at a time, each towards a filter that tested their polarization. With regard to Alain Aspect discovery, he was able to switch the measurement settings after an entangled pair had left its source. So the setting that existed when they were emitted could not affect the result. Next scientist is Anton Zelinger. His research group had demonstrated a phenomena called quantum teleportation. This particular term is very important from prelims perspective. Quantum teleportation is that thing which makes it possible to move a quantum state from one particle to another at a distance. So please keep a note of this term. Now we will discuss about what is quantum computing. It is very important from prelims perspective as one question is already asked in 2022 prelims paper. Quantum computing is a fast developing technology which uses the principle of quantum physics to solve issues that are too complicated for conventional computers. Just like a binary bit is the basic unit of information in classical or traditional computing, a qubit or quantum bit is the basic unit of information in quantum computing. In this particular image, you can see how a quantum computer works. It works on the principle of superposition, which allows parallelism in the calculation. If you see a particular coin, if you flip it, then there are two probabilities that either it will come into head or tail. So this is something which binary system do, like 0 or 1, that is head or tail of a particular probability. But in qubit, when you flip a coin and when it is in air, so there are many probabilities. This is what quantum computing or quantum bit does. It arbitrarily manipulates two-state quantum system. And there are various probability that what can come, we also don't know. So it is a very probable thing and it is a very important thing from various complex calculation. Now we will see the difference between quantum computing and classical computing. Quantum computing calculates with qubit which can represent 0 and 1 at the same time. In a similar way, if you will switch it, if you will flip the coin, so there are various probability when it is in air. So similarly, it can also represent head and tail at the same time. So similarly, quantum computing do 0 and 1 at the same time. And various other probabilities are also there when we use quantum computing. Whereas classical computing calculates with transistors, which can represent either 0 or 1. Quantum computing power increases exponentially in proportion to the number of the qubits. Whereas in classical computing, power increases in 1:1 relationship with the number of the transistors. The drawback of quantum computing is it have high error rate and it need to be kept ultra cooled. Whereas in classical computing, it have low error rate, so there is no need of keeping it extra cold. It can be operated at room temperature. Quantum computing is well suited for tasks like optimization problem, data analysis and simulation. Whereas classical computing can be used for everyday processing and they are used by everyone. So these are the basic difference between quantum computing and classical computing. Now we will discuss the phenomena of quantum computing and what are the principles on which quantum computing work. There are three principles: superposition, interference and entanglement, on which quantum computing actually works. Superposition enables quantum algorithm to utilize other quantum mechanical phenomena such as interference and entanglement. Interference is a consequence of superposition. Qubit state can interfere with each other because each state is described by a probability amplitude, just like the amplitude of the waves. Constructive interference enhances the amplitude, while the destructive interference cancels out the amplitude. Entanglement phenomena is multiple qubit can exhibit quantum entanglement, and these entangled qubits always correlate with each other to form a single system. Quantum entanglement phenomena is used to maintain the privacy of a particular data. China is already experimenting with these phenomena of quantum computing. Now we will see abilities of this particular thing. First one, climate change. Second one, discovery of new atom. Third one, drug discovery. Fourth one, personalized medicine. But it's not limited to these things only. It can be used in various other things. As quantum computing advances, we get closer to finding solution to some of the world's most challenging problems. While this new paradigm holds incredible potential, quantum computing is very much in its infancy. So there are only various few companies which are working on this particular thing. Now the major drawback of quantum computing is that it depends on adding more qubit. So if the particular qubit has high error rate, adding more qubit will result into very high error rate. But if a particular qubit has low error, so it will be of good use. So this particular thing make it very probable to high error rate. So these are the drawback of quantum computing. The main drawback is that to maintain its accuracy and to reduce its effective error rate is the main problem with regard to the quantum computing. One of the most significant hurdle in quantum computing is the fragile nature of the qubits. Entanglement of the qubit system with its environment, including the measurement setup, could easily perturb the system and cause decoherence. Therefore, advancement in quantum computing hardware construction and the error correction method are currently being developed. So it is in its infancy. We will find the solution and then we can use quantum computing. It will take some time, but whenever it will develop, it will be a new next generation technology. Now, let's discuss our prelims practice question. As I already told you that quantum computing is very important from prelims perspective. This year, this question was asked, which one of the following is in the context which the term qubit is mentioned? A. Cloud services. B. Quantum computing. C. Visible light communication technologies. D. Wireless communication technologies. So as you have already seen this video, you can easily answer this particular question. Now we will discuss yesterday's question. The word Denisovan is sometimes mentioned in media in reference to. So the correct answer for this particular question is B, an early human species. Now we will discuss our mains practice question, which says, discuss the steps that India can take to establish a suitable ecosystem for adoption of quantum technology and its application within the country. You have to answer this particular question in 250 words. Write your answers and send it to us on our WhatsApp number to get it reviewed. So this is all for today. We covered a very interesting topic on quantum computing. Stay tuned and stay updated with Analyst IAS to get to know more about these kind of topics. Thank you.